Welcome to today's lecture on section 3.1. We're going to go over the rectangular coordinate system that we use for graphing throughout this course. So as you can see, I do have a little bit of what looks like crosshairs here. This is the Cartesian coordinate plane. And we need to label a few things on here just to get a full understanding of what it is we're looking at. That being said, you can see that this horizontal line is what we would call it's what we would call the x-axis. Now, the x-axis is going to be our first movement, if you will, as we're going through our graphing process. More on that in just a few moments. This vertical axis is going to be the y-axis. So you have x and y axes. One is horizontal, that is x. The other is vertical, and that is y. Where these two intersect is a point called the origin. Now the origin is, if you think of these two axes as number lines, the origin is both 0 and x, 0 and y. Now, notice the notation that I used here. What I'm actually specifying is not an interval notation, but rather I'm looking at a specific location on the graph. What I'm talking about is an x, y coordinate. So anytime I have a value of an x and a y in such a format, I'm talking about a location that I can then use to graph. Notice that x is always first. Again, that is part of our first movement, left or right. And then we are looking at the y-axis moving up or down, depending on the value. Now, if we were to look at these four sections, this is what we call a quadrant. This is quadrant 1, and it moves counterclockwise to quadrant 2, quadrant 3, and quadrant 4. Now there's some unique properties to each one of these quadrants. If you were to look at values in this section of the x, from 0, think of this as a number line, from 0, you're moving in a positive direction. Now, that means your x values would be positive. Your y values, considering this is 0, up would be positive, down would be negative. So your y values in the first quadrant are also positive. So you can help easily identify what quadrant or where a point should be if you're looking at just the values without having to graph. Quadrant 2, just to specify, our x is going to the left of the origin, so that is zeros and then negative. So origin 0 going into the negative values, our x's are negative. Our y is going up, so we are looking at a positive y value. If you're looking at quadrant 3, you have negative x's, and now you have negative y's. If you have quadrant 4, notice that your x's are positive, but your y's are negative. And so you can see with these four quadrants that they are kind of opposite of each other. As you're looking from quadrant 1 and 3, your odd quadrants, either you're double positive, so positive x, positive y in quadrant 1, or you're double negative, negative x and a negative y in quadrant 3. Likewise, notice that in your quadrants 2 and 4, your values are either negative positive or positive negative, depending on if you're in quadrants 2 or 4. Now, all of this information is more theory than anything else, but it does help you to really start understanding where graphing occurs. As you cross an axis, on any axis, it doesn't matter, but if you were to have a point on the axis itself, that is what we call an intercept value. Now, this intercept has a location, and that means one of your axes will have a 0 value. So for this particular point, this is what we call the x-intercept. For any value that's crossing on the x-axis, anywhere, it could be over here, it could be over here, and your x-intercept will have a value of 0, will have a value of I'm thinking of the y-intercept, will have a value of a, so any value doesn't matter, along your x, and 0 for your y. I'm trying to jump ahead of myself in my speech, and I know I need to slow down. Okay, if you were to put a point here, have a stop on the y-axis, or you're crossing the y-axis at any point, this is what we call the y-intercept. And this one has 0 movement in x, but it has some kind of movement in y, and so we call that 0b. A and b for your intercept values are just some number. That's all we do is we put an a or b for representation. Okay, with that being said, let's try a few graphing points. So I do have some points available on your notes. I'm going to just list all of my points here. And let's make sure that's nice and clear. Very good. And I'm also going to get some space right here on my chart. So I'm going to erase my notes from here. There we are. That way we have a nice, clean chart. Okay, and we're going to fill those spots back in just really quick. There we are. Okay, very good. Now, if we're looking at point A, the question is, what quadrant is point A in? Notice that both x and y are negative. And so if you're looking at where point A should be, it should be here in quadrant 3, where you have both a negative x and a negative y. So here's how it works. My chart here, my plane, is not perfectly to scale. But if you're using the printed version on your paper, or if you have grid paper, you can get this perfectly to scale. Mine is not perfectly to scale, but you can get the basic idea. So from the coordinates of point A, we would need to move 4 units in the negative x direction, and then 5 units in the negative y direction. So my point A would be at negative 4 for the x, negative 5 for the y. And if I had grid lines that went all the way through, the intersection of those two areas, those two valued lines, would be right here at point A. Pretty easy. Let's talk about point B. Notice point B has a 0 for the y value. And what that means is we are now looking at an x-intercept. So this is a great example of an x-intercept. So at B, we are looking at 2 units in x, 0 units in y. So that means B is sitting right here on the axis at 2, 0. Where is C? Notice C has a 0 for the x. This indicates that we are now looking at the y-intercept. So at 0, we're not moving left or right, but we are moving straight down 4 units, and there is our point C. So all we're doing at this particular time is graphing random points, but we will get far more organized in just a little bit. For point D, what quadrant would point D reside in? You have a positive x, you have a negative y. So that would mean that you're looking at positive x's, negative y's. You're right here in quadrant 4. So positive 3 would mean we're here, and negative 6 would bring us down. We had to add one more tick line. would bring us down right there. And that would be our point D. Okay, so that's pretty straightforward as you're going through the graphing process. Do not get confused in your x's and your y's as far as which direction moves first. X always moves first, and then y. Excellent. Now, let's go ahead and clear my space a little bit. I am going to leave my chart up here. I'm going to erase a little bit of information because I will need it in just a little bit. But we won't need it for this next problem. So this next problem gives us an equation of x plus 4y is equal to 8. And then it gives us a chart, an xy chart to be precise. And it has 3 row values to it. We have a 0 for the x, a 0 for the y on the second row, and then a 3 for the y on the third row. Now, as we're looking at this particular problem, it says complete the table of ordered pairs for the given linear equation. How? Very good instructions, right? How do we do this? Well, what we're given are values, and you can think of these as input values. Now, typically, for an XY chart, your input would be X, your output would be Y. However, some of the values that you're given in this problem are Y values, and so you have to plug those in and just work through and find X. It's not a big problem. So this is what we're going to do. We're going to plug in 0 for X and solve for Y. 0 plus 4y is still 4y, that's beautiful, is equal to 8. Divide by 4, y equals 2. This y value goes into the chart. So we have a point of 0, 2. Pretty easy. All right, let's try the next one. Got my squiggly line just to divide. So I have x, don't know what that is, plus 4y, my y is 0, is equal to 8. 4 times 0 is 0. X plus 0 is x. So I have x is equal to 8. That x value goes into your chart. Okay, one more time. Let's try the next one. So I have x plus 4y. My y value is 3. And that equals 8. This one takes a little more work. I have x plus 12 equals 8. Solving for x, I'm going to move that 12 over. That means x is equal to a negative 4. Plug that value back into the chart, and there is your chart. Now, the awesome thing about an XY chart, and the reason it's so powerful for graphing at any level, is that it gives you your coordinate values. So notice that if you were to look at an XY coordinate value, it's looking for both X and Y values. But you can use the values of a chart to help organize that information. So you would have points here of 0, 2, 8, 0, and negative 4, 3. And then you could plot these 3 points easily on a Cartesian coordinate plane. We're not going to for this problem. Trust me, we will get plenty of practice with that later. But keep that in mind. XY charts are going to be one of your best friends. Okay, let's get some more room here. So the next question that we have says, determine whether each ordered pair is a solution of the given linear equation. And that is 3x plus y equals 8 is our first given linear equation. They give us points of 2, 3, 0, 8, and 8, 0. So determine whether each ordered pair is a solution of the given linear equation, which means we should be able to plug in both x and y into our equation, and then we should be able to balance that equation. If you have to solve it all the way down, you should get a true response of something equals itself. So what we're getting here, if we were to plug in our first point, is 3 times 2 plus 3 for the points of 2, 3 is equal to 8. Simplify this out. That's going to be 6 plus 3 is 9 is equal to 8. Does 9 equal 8? No. So that is a false response. This is not a point of the solution. It is not an ordered pair that will work. Very good. Let's try the next one. I'm going to box this off. My original equation is on the top. My next problem is 3 times 0 plus 8 is equal to 8. 3 times 0 is 0. 0 plus 8 is indeed 8. So I have 8 equals 8. That is true, always true. So this coordinate pair, this ordered pair, is a solution of our equation. Let's just try the last one. I have 3 times 8 plus 0 is equal to 8. 3 times 8 is 24 plus 0 is still 24 is equal to 8. 24 is not equal to 8, so this is not a solution. Now, what does that actually mean? If we were to graph our points and we were to graph this equation, only one of those 3 points would actually be on the line of what our equation is graphed. The other 2 points would not be, and so they are not solutions to this equation. Excellent. Let's try the last problem here. So the last problem is x equals 7, and they give us points of 3, 7, 7, 0, and 7, 2. And again, same instructions, determine whether each ordered pair is a solution of the given linear equation. How do we plug in for a variable we don't see? Interesting. Because I see x, but I don't see a y. How very interesting. But do you see a y if you were to put in 0, y? Absolutely. And that's because 0 times y, doesn't matter what y is, 0 times y is going to still cancel out. It's still going to be 0. And so you haven't changed your problem at all by adding in 0y. Okay, so let's just see what we get. Let's plug in and see what we've got. That gives me 3 plus 0 times 7 is equal to 7 for the first coordinate. 0 times 7 is 0, plus 3 is 3, so 3 equals 7. Does that make sense? No. So this first ordered pair is not a solution. Get my squiggly lines to divide out. Let's plug in that next point. I have 7 plus 0 times 0 is equal to 7. 0 times 0 is 0, plus 7 is 7. 7 equals 7. That is true. So that point works. Let's try the next one. I have 7 plus 0 times 2 is equal to 7. 0 times 2, 0. Plus 7 is 7 is equal to 7. So that also works. So that means that these 2 points are on the line. Now, in this particular case, x equals 7 is a very special kind of line. It's actually going to be a vertical line, and we'll talk more about those in a future lecture. For now, that concludes section 3.1.